Okay, so we're going to think about the problem of finding the symmetries of an equilateral triangle and mapping them in a Cayley diagram. And when we define a symmetry in this course, we're actually thinking about it as an action, as something we're doing to a shape. So in this case, we have an equilateral triangle and we've labeled it according to the guidance in the textbook. So we start off with a 1 at the top and then label it counterclockwise, or sorry, label it clockwise, I should say, with a 2 and then a 3. Okay, so 2, 3. Um, just labeling it in order is really the most important thing, and labeling it in a way that you can remember. And usually if you have a physical shape, shading the front, uh, and versus the back is also helpful. Just having a distinguishing mark between the front and the back. In this case, when I flip it, I'm going to see backwards numbers, so that's how I'll know that I have a back and a front. Okay. Um, and so what is a symmetry? Well, I'm in Canva right now, so I'm going to actually see some of the actions happen. So one of the ones that Canva does really easily is a flip. So I could flip horizontally. And when I do a horizontal flip, if the shape wasn't labeled, you wouldn't be able to tell that I had done that action if I had just seen the beginning and the end point. But if I flip the vertically, you'd be able to tell. Like you'd be able to tell that the first one looks like the old food pyramid and the second one looks like um, the new American food pyramid or the upside down pyramid. Um, so that looks like an upside down pyramid. This one looks like our right side up pyramid. They look like very different shapes, right? So a vertical flip in this case is not a symmetry action, okay? But a horizontal flip is a symmetry action. So when we want to map symmetry actions, we just start with our home base position and we start to draw them out. I don't know if I can make a bigger node here. Maybe I'll just leave it like that. Okay, so I'll take my first position, and the second one is the result of flipping it horizontally. So these two shapes look the same, they're just labeled differently. And actually, in my map, I also want to know what happens when I flip the second one horizontally too. What do I get when I flip this horizontally? And I can see, well, I just get back to my original, right? So this arrow is actually going to be two directional. So the red arrows in my diagram are going to always denote a horizontal flip. And that's as far as I can get with just horizontal flips. And I certainly know that the equilateral triangle has more things that I can do with it that will keep it the same. So I can go on and label another symmetry action. Now, there are a couple choices we have. I'm going to label the next one as a 60-degree clockwise rotation. I'm going to put it over here. So I'll copy the shape. And then what happens when I rotate it 60 degrees clockwise, I'll end up with the 3 on top. And you'll see Canva labels it slightly differently, but hopefully you're okay with that action. And I end up like that. Okay, so I can also perform, again, these symmetry actions on each of the shapes. So Usually when you rotate, you kind of want to keep rotating. So I'm going to take this shape again, this arrow again. And keep rotating it. So if I rotate it again 60 degrees, I'll end up with the 2 on top. Okay. And if I rotate it again 60 degrees, you'll probably see right away that I'll end up back in my kind of home base position with the 1 on top. Okay. So what happens if I rotate this backwards flipped version 60 degrees? So if I rotate it 60 degrees clockwise, I'll end up with the 2 on top. So usually when people start drawing their Cayley diagrams, they look like this. Okay. And then they kind of do the same thing. Rotate this 60 degrees again. End up with a 3 on top. And so on. Okay. This is actually not the best way to draw this Cayley diagram. And the reason that we see is when we start to connect the red arrows. So it's not enough to just have a connected Cayley diagram. We know we have enough generators when we have a connected Cayley diagram. However, we need to fill in all of the generators with every position. That is, we have to say, in this case, what the horizontal flip does to each of these positions. It's not enough to just say what it does to the identity. Okay, so what happens when we do a horizontal flip to the one where we have the 2 on top in the backwards position? So when we do that, it actually ends up with something much different than what I would say. Okay, so when I do a Canva horizontal flip, that's not a horizontal flip as far as I'm concerned, right? It's actually taking a horizontal flip with respect to like the original orientation. So I have to be careful here. Canva horizontal flip and a computer horizontal flip is going to be different than our um like our mathematician horizontal flip. Okay, and this is one of the things that I want to warn you about. So horizontal flip, um, from a mathematician's perspective, is always going to be with the same shape, upright, the corner pointing upwards, and flip along the vertical axis. Okay, that is, make a flip that is a horizontal reflection. Okay. So oftentimes we don't say this is horizontal flip. We'll say make flip along along vertical line. Okay. So even though this is like Canva horizontal flip, we'll say make flip along a vertical line, like the center vertical line. So again, you'll see when I ask Canva to do this, that's not what they're doing, right? They're always doing it the horizontal flip is always with respect to their like original orientation. Even though I've rotated the shape, they still have the original orientation in mind. Okay, so I can't do the flip very easily with Canva. This is where I really need to have my physical model there. But if I imagine a flip along a line, and let me actually just grab a line here. I'm going to make a new line. So if I make a flip along this vertical line here, you'll see that the 2 at the top will stay in place and the 3 and the 1 will switch positions, right? So that will mean that actually this will be connected to this via this horizontal flip. And likewise, when I do a flip along this vertical line through 3, 1 and 2 will change positions, but 3 will stay in line. So these two will be connected via the horizontal flip or the flip along a vertical line. So there's some ambiguity that really needs to be clarified here. And so that's why we don't usually write the inside rotations clockwise. What we would do is we would write these arrows counterclockwise so that we wouldn't have this weird crossover here. This is still correct if I write it like this, but it's just a little abnormal. Okay, so this group that we have, this set of symmetries of the equilateral triangle has 6 elements. Each of these positions is a position that represents a symmetry of the equilateral triangle. And each of them also corresponds to an action. Okay, so for example, this position in the lower right-hand corner corresponds with the symmetry action. Rotate 60 clockwise and, well, and that's it. Rotate 60 clockwise. That's all I have to do there. But it also corresponds with the same action. I could follow the red arrow, and then I could follow a blue arrow, and then I could follow another red arrow. Oops, sorry. Okay, sorry, I could follow a red arrow, then I could follow a blue arrow, then I could follow another red arrow. Where do I want to go? Let me see. So I'm trying to find another pathway over here. So what's another pathway over here? Maybe a better way to express that is to instead say I follow a red arrow, a backwards blue arrow, and then a red arrow, right? So another way to express that is to say flip, then rotate. Actually, let me move this text box so it comes in frame. Then rotate 60 counter, then flip, right? Flip, then rotate 60 counterclockwise, then flip. That should get me to the same position. And that also means that anytime I have an equilateral triangle, the action of rotating 60 clockwise is the same thing as flipping, then rotating 60 degrees counterclockwise, and then flipping again. And this position gives me a formula, but I also want to show you that those arrows give me a formula too. And this is something that we're going to see throughout the course. This is a little bit of a preview. Okay, so this position is giving me a formula because this position is represented by like two different sets of actions. But if I start off at any given point in the diagram and see where I get, I'll get to the same place if I follow these two sets. Okay, so let's say I start off here. Okay, so I'm going to say start. Okay. So if I rotate 60 degrees clockwise, then I will end up here. Yet another text box to indicate that this is the finish. Okay. Now, that should be the same thing. I should end up, if I start here and finish here, that should be the same finish point as if I then flip, rotate 60 degrees counterclockwise, then flip again. So if I start here, I'm going to flip, end up here. And if I rotate 60 degrees counterclockwise, I end up here by following that blue arrow backwards. And then I'm going to flip again. And look, I end up in the same finished position. So these diagrams are conveying a lot of information. They're not only indicating all of the different symmetries, they're indicating how we can navigate those symmetries and how the actions are connected. Okay, so that's a little bit about how you can build the Cayley diagram for an equilateral triangle, and then also how it is connected and how you can navigate it.